It's the year 1950. In a quiet office in Manchester, England, a man sits hunched over his desk, writing a paper that will change the world. His name is Alan Turing, and on the first page, he types a question no scientist has ever dared to treat seriously. Can machines think? Most people would laugh. Computers at the time are room-sized monsters that can barely do arithmetic. But Turing isn't most people. And that single question is about to spark a 70-year journey, full of triumph, heartbreak, frozen winters, and a comeback nobody saw coming. So, was AI really born in 1950? Stick around, because the answer is more surprising than you think. But to understand 1950, we have to go back. Way back. Thousands of years ago, the ancient Greeks told stories of Talos, a giant man made of bronze who patrolled the shores of Crete, protecting the island without rest, without sleep. A machine with a mission. The dream of artificial beings was already alive. Fast forward to the 1840s. A brilliant mathematician named Ada Lovelace is studying a strange mechanical contraption called the analytical engine, and she sees something nobody else sees. This machine, she writes, could one day manipulate not just numbers, but symbols, music, language, ideas. She glimpsed the future 100 years too early. Then, in 1943, while the world is at war, two scientists, Warren McCulloch and Walter Pitts, publish a paper describing something extraordinary: artificial neurons. Simple mathematical switches modeled on the cells of the human brain. The seed of the neural network is planted. It just needs someone to ask the right question. And that brings us back to Alan Turing, alone at his desk. Turing knows that philosophers could argue forever about what thinking really means. So he does something genius. He sidesteps the debate entirely and proposes a game. Picture this. A human judge sits in a room, typing messages to two hidden players. One is a person. The other is a machine. The judge's job? Figure out which is which. If the machine can fool the judge, if its words are indistinguishable from a human's. Then, Turing argues, we must admit the machine can think. Today, we call it the Turing Test, and with it, an ancient dream became a scientific experiment. This, right here, is the moment many call the birth of AI. But a newborn needs a name, and that name came 6 years later. Summer, 1956. Dartmouth College. A young professor named John McCarthy gathers a small group of dreamers, Marvin Minsky, Claude Shannon, Nathaniel Rochester, for a workshop with an audacious premise: that every feature of human intelligence could be described so precisely, a machine could simulate it. To describe this new field, McCarthy coins a phrase the world has never heard before: artificial intelligence. The field is officially born. The dreamers leave Dartmouth convinced that thinking machines are just around the corner. Some predict it will take 20 years, maybe less. They had no idea what was coming. Hey, if you're enjoying this story so far, do me a quick favor and hit that like button and subscribe. It helps the channel more than you know, and there's a lot more story left to tell. Now, back to our tale. Because things are about to go very wrong. At first, the magic seems real. In 1958, Frank Rosenblatt unveils the perceptron, a machine that can actually learn to recognize patterns. In 1966, a chatbot named Eliza holds simple conversations, and people are stunned. Some users even believe they're talking to a real person. The headlines are electric. Machines that learn. Machines that talk. But behind the curtain, there's a problem. The computers are painfully slow. Memory is tiny. Digital data barely exists. The grand promises keep slipping further away, and the funders start asking hard questions. By the 1970s, the money dries up, labs close, careers stall. The field falls into a long, cold silence that researchers still call the AI winter. There's a brief thaw in the 1980s when businesses pour money into expert systems, programs stuffed with human knowledge, rule by rule. But they're expensive, fragile, and impossible to maintain. The bubble bursts. A second winter sets in. The dream of Dartmouth, it seems, is dead and buried. Until one night in New York City, May 1997. The world chess champion, Garry Kasparov, arguably the greatest player who ever lived, sits across the board from an opponent that doesn't sweat, doesn't blink, and doesn't feel fear. IBM's Deep Blue. Game 6, the world is watching, and in just 19 moves, Kasparov resigns. For the first time in history, a machine has defeated the reigning world chess champion in a full match. The world gasps. AI is back in the headlines, and behind the scenes, something even bigger is brewing. Because as the millennium turns, two missing ingredients finally arrive. The internet explodes across the globe, and billions of people begin generating oceans of digital data. Photos, emails, videos, websites. At the same time, computing power skyrockets. Data and power. The two things the pioneers never had. The stage is set for a resurrection. In 2006, a researcher named Geoffrey Hinton, who spent the winter years stubbornly believing in neural networks when almost no one else did, co-publishes a paper that revives the field under a new name, deep learning. Networks inspired by the human brain, stacked layer upon layer, hungry for data and computing power. And now, finally, the world can feed them. The victories come fast. In 2011, IBM's Watson beats the best human champions on the quiz show Jeopardy! A machine understanding wordplay and riddles. In 2012, a deep network called AlexNet stuns the research world by recognizing images with unheard-of accuracy. In 2016, DeepMind's AlphaGo defeats Go legend Lee Sedol at a game so complex, experts said machines wouldn't master it for another decade. Then, in 2017, researchers at Google introduce a new architecture with a modest name, the Transformer. Using a trick called self-attention, it can read entire sequences of text and understand how every word relates to every other word. Almost nobody outside the field notices. But this quiet paper is the spark of everything that comes next. In 2018, OpenAI uses transformers to build the first GPT, a large language model trained on vast amounts of human text. Each new version grows more fluent, more capable, more uncanny. And then, in late 2022, they wrap it in a simple chat window and release it to the public. ChatGPT. Within months, hundreds of millions of people are talking to an AI, asking it to write essays, debug code, plan trips, explain the universe. Turing's imaginary game, the one he sketched at his desk in 1950, is now something anyone can play from their phone. And AI doesn't stop at conversation. It generates images and video from a sentence. It helps doctors read scans. Systems like AlphaFold predict the structures of millions of proteins, accelerating drug discovery in ways scientists once thought impossible. So, where does the story go from here? Researchers point to AI agents, systems that don't just answer, but act, planning, booking, building, completing entire tasks on our behalf. To multimodal AI that sees, hears, and speaks as naturally as we do. To breakthroughs in medicine, science, and education that could touch every life on Earth. And with all of it come the hard questions. How do we keep AI safe? Fair? Honest? Governments around the world are writing the rules right now, and scientists still debate when or whether machines will match human intelligence across the board. Nobody knows the ending, because this story is still being written. So, was AI born in 1950? The dream is ancient. The name came in 1956. But 1950 was the moment a lone mathematician turned a myth into a question science could answer. Every chatbot, every image generator, every AI assistant today is, in a way, a descendant of that one typed line. Can machines think? 70 years later, the machines are answering back. Thanks for watching. If this story kept you hooked, hit like, subscribe, and turn on notifications, because the history of AI is still unfolding, and you won't want to miss the next chapter. Until next time, keep learning.